So today we are going to wrap up Unit 2 and we are going to step into Unit 3 of AP Calculus. And our first video is going to be something called the implicit differentiation. Now, the implicit differentiation is not actually the first thing you learn in Unit 3. It's actually the product rule, but I grouped it into Unit 2 because for me it feels more natural and I thought it's really a natural step after the power rule. Okay, so let's start Unit 3. Now, for implicit differentiation, I've also used it a little bit in previous proofs, I believe. It's basically just differentiating both sides of the equation and grouping up the dy dx's and finally finding the value of dy dx. So there's also a procedure of doing implicit differentiation I'm going to explain. So the first step is we need to treat our y as a function of x. So we treat y as a function of x. In other words, y is equal to y of x. Okay, so what that means is when we differentiate terms involving y, we're not just calculating the derivative of the term, but also we need to times or multiply dy dx, because again, y is the function of x. Now, secondly, when we deal with product terms, okay, we need to use the product rule, which we proved. So I'm gonna give you a short example. For example, if we have xy as a term and we want to differentiate this term, then by the product rule we have the product of x is 1, so y plus now the derivative of a y is 1, but we need to times dy dx because y is the function of x. So here we have x times dy dx. So something like this, just trying to give you a sense of what this looks like. Now finally, like after all these, we need to obviously solve our derivative, and our last step is going to be collecting our dy dx's. Okay, so basically after you differentiate all the terms, you have a bunch of dy dx's. You are going to isolate the dy dx to find the derivative. So it's a fairly simple step. I'm not going to really talk much about this. So yeah, let's start our first example on implicit differentiation, which is x cubed plus y cubed is equal to 6xy. Now, this is actually a really famous equation or function called the Folium Descartes. Yeah, it's the person that invented the x and y axis and stuff. So yeah, let's start doing implicit differentiation. Now, the derivative of x cubed is 3x squared, simple. And the derivative of y to the 3 power y cubed is again 3 times y cubed. But remember, we need to times dy dx, therefore dy dx. Okay. Now here, as I said, is a product term. What we need to do is also fairly simple, just basically this. So the derivative of 6x is 6, and then y, we don't change y, plus, now we also don't change 6x, so 6x right here. And the derivative of y is dy dx, as we just mentioned. Now we're going to group, or we're going to collect dy dx's. So let's move this term to the left, and therefore we get 3 times y squared minus 6x. Okay, collectively we have dy dx on the outside, and then 6y, we are going to move this term onto the right side, which minus 3x squared. Okay, now we divide both sides by this, therefore we get dy dx is equal to 6y minus 3x squared over 3y squared minus 6x. And if we simplify this a bit, the answer we are going to get is 2y minus x squared, divided by y squared minus 2x. Okay, pretty simple, pretty intuitive. And so now I really wish that I could prove the implicit differentiation, but the proof of this involves something called the implicit function theorem, which is somewhat the multivariable calculus advanced stuff, which stands way beyond AP calculus. So I'm going to leave it like that, but I am going to use a very simple example to show that no matter if we first isolate the y and get the derivative, or if we use implicit differentiation, we're going to get the same thing. So let's write our example here. So for example, if we have a x squared plus y squared is equal to 25. Now let's first use implicit differentiation to get the dy dx. I'm just gonna do this real quick. Okay, dy is equal to 0, therefore dy dx is equal to, now move this here, divide 2y is going to be negative x over y. Okay, so this is our derivative found by implicit differentiation. Now, on the right side, we're going to first isolate y and then find the derivative. So y squared is equal to 25 minus, oh my god, this 25 is insane. So 25 minus x squared. And then, so y is equal to radical 25 minus x squared. And differentiating this, we are going to use the chain rule. So the derivative of this function collectively is 1 over 2 radical 25 minus x squared. And then we times the derivative of the inside of this square root. And therefore, this is negative 2x. So negative 2x. And we further simplify this. Therefore, we get negative x over square root of 25 minus x squared. Now, notice that y is equal to radical 25 minus x squared. So we can basically substitute y into our expression. Therefore, we get negative x over y. So notice that the two derivatives we get from the two methods are exactly the same. And so we've somewhat proven that the implicit differentiation is a liable method. So I hope you enjoyed today's video, and I'll hopefully see you in the next video.